Okay, guys, so in this question, we are going to review cylindrical coordinates. So this is a triple integral that we are trying to compute over x multiplied by y. Okay, and then the solid that we are going to compute this over is a paraboloid. So the paraboloid is going to be your ceiling, and the xy plane is going to be your floor. And now also they're saying that it's the first octant. So whenever they say the first octant, what they mean is that x, y, and z are all three positive, and that's going to really make it a quarter of that solid. So it's not going to be the whole thing, but just a quarter that sits in the first octant. How would this look like? So if x and y are both zeros, then z will be 64. Obviously, I cannot draw it to scale, but I can just say that this is 64 right here. And then the intersection of this with the xy plane is going to be interesting, right? So what is going to be the intersection of this paraboloid with the xy plane? So you all know that xy plane is z equals 0. So that means that 64 minus x squared minus y squared will become 0. In other words, x squared plus y squared will be equal to 64. And hopefully you recognize that that is equation of a circle centered at the origin with radius of 8. Okay, so you're gonna have radius of 8, but it's not gonna be the whole thing, again, because this is just the first octant. So this is just gonna be this part right here. Okay, and then the here from here to here will look like a parabola, right? So something like that. So you can imagine that the solid will be bounded by above by the paraboloid and below by the xy plane. And then what you will need to set it up would be the projection of the solid onto the xy plane, which will be the quarter of a circle. So let's see if we can switch this to cylindrical coordinates. Number one, for cylindrical coordinates, you want bottom surface to the top surface, but they already told you that. They said it's bounded below by the paraboloid and above by the xy plane. So the xy plane is on the bottom, which is z equals 0. So that'll be here. And then on the top, you're going to get that paraboloid 64 minus x squared minus y squared. And I think you should already by now know that cylindrical coordinates x squared plus y squared equals r squared. So that is true if in 2 dimensions when you had polar, and in 3 dimensions when you have cylindrical. So this thing, 64 minus x squared minus y squared, will just be written as 64 minus r squared. Okay, over here, you want to set this up over the projection of the solid on the xy plane. And as I said, that's a quarter of a circle. Now, this is done similar to polar coordinates. First of all, so just imagining a two-dimensional situation, right? You're gonna have a fixed theta. So if you fix an angle, let's say you fixed an angle, how would the r change, the distance to the origin? So because this is a circle of radius 8, r is going to go from 0 to 8. And then the angle theta would be responsible for this rotation from 0 to pi over 2, right? Because this is just 1/4 of a circle, not the whole thing. And then here, as I said, that's going to be 0, 8. And so the order of integration is going to be dz, dr, d theta. Now, not to forget immediately, I'm going to add the Jacobian, which is r, which is that extra r that comes out of switching from rectangular coordinates to cylindrical coordinates. Now, if they said compute the volume of the solid, we would be done. Like this would be just r dz dr d theta. But they're not asking the volume, they're asking x times y. Now, a lot of times in problems with cylindrical coordinates, you will see that the integrand is something like x squared plus y squared, where you just immediately change it to r squared, but not in this case. In this case, you see x times y. So you cannot simplify that. So you just have to use the definition. In cylindrical coordinates, x is r cosine theta and y is r sine theta. So that's what you need to keep. So x times y is going to be, if you multiply these, this is going to be r squared cosine theta multiplied by sine theta. Okay, so that's the setup. Okay, now let me show you how to compute something like that. So let me first of all simplify this a little bit. So this is going to be 0 to pi over 2, 0, 8, and then here 0 to 64 minus r squared. And then I'm going to combine the r's together into r cube. And then this is cosine theta, sine theta, dz dr d theta. Now, this integral by itself right now is not splittable, because remember that we can split integrals only when the limits are all constants, and then the integrand is a product of something that just say has z, and then something that has r, something that has theta. It is a product, but I highlighted the limit, one of the limits, and it does have a variable in it, so we can't split it yet, but we will be able to split it the moment we integrate. Now, this is going to be the inside integral. All of this stuff does not depend on z, so you can think of it as a constant, and so we're just going to rewrite it and multiply it by z. So just like integrating 5 will produce 5z, so does integrating r cubed cosine theta sine theta will also produce r cubed cosine theta sine theta z. Okay, and then we substitute. Very important to write for what you are substituting, because you have now 3 different variables. So this is z equals 0, z equals 64 minus r squared. Okay, and then since I already integrated z, this will be dr d theta. All right, so from here, I am going to wind up with, obviously at 0, this is just going to be 0. So this is r cubed cosine theta sine theta. And instead of z, I plug in 64 minus r squared. Now, at this point, this integral is splittable because you do have only constants in the limits, 0 and pi over 2, 0, 8. And also, when you look at the integrand, it is a product of something that just has r and something that just has theta. So let's split this apart into 2 single integrals. So I'll have sine theta cosine theta integral. And then I'm going to multiply that by r cubed 64 minus r squared dr integral. All right. How do we handle that? So the first integral is handled by substitution. U equals sine theta. And that means that du will be cosine theta d theta. So this is a very simple integral. This is u. And then this right here, all of that, that's just going to be du. And so the integral of u du will just be u squared over 2. But because u is sine theta, I'm going to get sine squared theta over 2. And then I'm substituting 0 pi over 2. For the second integral, you have to, before you integrate, you have to distribute. So that will become 64 cubed minus r to the 5, okay? And now I can just integrate that using the power rule. So 64 r to the 4th divided by 4 minus r to the 6th divided by 6, and I substitute 0, 8. Okay, so if you plug in pi over 2 into sine theta, that is going to be sine of pi over 2, which is 1. And then 1 squared is 1. So that's just going to be 1/2. If you plug 0 into sine, that is 0. So that's all there's going to be from here. Now 64 divided by 4, I think that would be 16. And then you multiply that by 8 to the power 4 minus 8 to the power 6 divided by 6. I do not think that we really need to simplify this any further. I think this is fine. If the teacher requires, you can put it on a calculator and convert it to a fraction answer. But other than that, that's it.